All right, the other day we looked at section 10.1 and we had a lot of rules for exponents. Today we're going to add 2 more rules to our list. What were some of our rules for exponents? What kind of rules did we have? All right, so that was probably rule number 2. I think rule number 1 was just a definition. B to the m means to multiply b times b times b m times. And then rule number 2 was when you're multiplying things together, what happens to the exponents? You add them. And rule number 3, I think, was when you're dividing things that have the same base, what happens to the exponents? You subtract them. And this one, we had to be careful. B could not be the number 0. Can't divide by 0. What other kind of rules did we have? What happens if you have an exponent followed by another exponent? That's when you multiplied the exponents. How about if you have a negative exponent and that negative exponent is up on top? To make it positive, you put it on the bottom. That's exactly right. So we get rid of negative exponents by moving to the bottom. And again, b can't be 0. Conversely, rule number 6, if we have a negative exponent, but the negative exponent is already on bottom, what happens to negative exponents on bottom? They move to the top. So all negative exponents do is interchange top and bottom. A negative exponent on top goes to the bottom. A negative exponent on bottom goes to the top. I think we had a couple more rules. What if I have 2 things being multiplied together and I have an exponent on the outside? Each one gets the exponent. That's a distributive type property. And the same thing worked for fractions. If I have a fraction with a parenthesis on it and an exponent like so, the top gets the exponent, the bottom gets the exponent. Again, that one b can't be 0. Can't divide by 0. And then I think there was one more rule that I forgot to mention the other day. And I think the last rule was, what if you have something to the 0 power? It's just that number? So 5 to the 0 should be 5? Okay, what's 5 to the 1? So does it seem like 5 to the 1 and 5 to the 0 should be the same number? No, probably not. How about this? How about if I were to write 5 cubed over 5 cubed? What's 5 cubed over 5 cubed? Well, what happens? Well, 5 cubed is just a number, right? Happens to be 125. What happens when you take 125 and you divide it by 125? You get 1. On the other hand, 5 cubed over 5 cubed, I'm dividing, so what could I do to my exponents? I could subtract them. I would have 5 to the 0. So what should 5 to the 0 be? 5 to the 0 should be 1. So that was rule number 9. B to the 0 is always the number 1. And again, I have to have a little rule. The little rule is b can't be the number 0. What's wrong with the number 0? How come b can't be the number 0 here? Well, can I do the same trick? Could I take 0 cubed divided by 0 cubed? No, I can't do the same trick. What's wrong with 0 cubed divided by 0 cubed? I can't divide by 0. So that same trick doesn't work with 0. So 0 to the 0 just isn't defined. We don't talk about 0 to the 0. Okay, so those were all of our rules from last time, plus rule number 9 that I forgot to mention. Not a big one, though. Today, we're going to have 2 new rules. We'll have 10 and 11, and that'll be all of our rules for exponents. The title of this section is Rational Exponents. What's a rational number? What does rational mean? These rules that we had were all for integer. No, these were even better. These were counting numbers. M and N were numbers like 1, 2, 3, 4, 5. What are rational numbers? Give me an example of a rational number. 3/4 is a rational number. Why is 3/4 a rational number? It's a fraction. Rational numbers are fractions. Or decimals, but a special kind of decimals. What special kind of decimals? Like 3/4 would be 0.75. That's a decimal that we say terminates. It ends. 2/3 would also be a rational number. What's 2/3 as a decimal? .6666 going forever. That's called a repeating decimal. So rational numbers can be written as fractions. They can also be written as decimals, or decimals that end, or decimals that repeat. We're typically going to deal with fractional powers in this case. So, for example, we might have something like 9 to the 1/2. That would be a rational exponent. How much is 9 to the 1/2? Well, I'm not sure. But I do know if I take 9 to the 1/2 and then I square it, what do? I've got a power, a parenthesis, and another power. What does rule number 4 tell me about having a power and another power? I multiply them. So I take 1/2 times 2. What's 1/2 times 2? 1. So I end up with 9. So if I take 9 to the 1/2 and I square it, I get the number 9. What other number do you know that I could take and I could square it and I could get the answer 9? 3. So 3 squared is also 9. So how much is 9 to the 1/2? It seems reasonable that it ought to be 3. So what's another name for that? That's the same as the square root. So 9 to the 1/2 is the square root of 9, which is 3. So rational exponents are going to give us roots. So that's rule number 10. Rule number 10 is b to that power, b to a fractional power, 1 over n, is the same as the nth root of b. Whatever number is on bottom, that number gives you your root. So how much is 27 to the 1/3? Well, what does that 1/3 power mean? That's a cube root. That's correct. 27 to the 1/3 would mean cube root of 27. Cube root of 27 is 3. How about 16 to the 1/4? Well, that 1/4 power means to do a 4th root. So that's the 4th root of 16. And the 4th root of 16 is 2, because 2 times 2 times 2 times 2 is 16. All right, how do you do these on your calculator? Where's the 4th root button? Anybody know? Math number 5. Okay, but before you can do math number 5, here's what you need to do. If you want to do 4th root, you type the number 4 first, and then you go math down to number 5. And notice what it did. On my calculator, I have the new one. It puts the little 4 where that x was. If you have an older calculator, it's actually going to write that symbol. It's going to write the x and the root symbol. But it's plugging that 4 in for the root. So 4th root of 16. My calculator tells me it's 2. I actually think he was smacking down his pack of cigarettes.
Oh.
You know. That's what it looked like as he walked by.
A victory's a victory.
A victory's a victory. Or, of course, I could do 16 raised to the 1/4. Now, again, if you have an older type calculator that writes the little caret symbol, you're going to have to put that 1/4 in parentheses. Mine, the newer one, it gives me the little exponent thing. I can type it in just like it looks. But if you have an older calculator, you're going to have to do 16 caret and then put the 1/4 in parentheses. All right, and then our last rule. What if I don't have the number 1 up on top of my exponent? What if I have b raised to the m divided by n? Well, I'm going to write this way. This is b to the 1 over n raised to the m. How come those are the same thing? Well, what do you do when you have an exponent and then a set of parentheses and another exponent? You multiply them. What's m times 1 over n? Well, you think of m as being m over 1. You multiply the tops, you multiply the bottoms, you get m over n. So, this is an nth root of b to the power m. So, a fractional power. All that happens is the number on bottom tells you what root to do, and the number on top tells you what power to do. If I were to give you 4 to the 3 halves, that's got a 2 on bottom. So what's a 2 on bottom tell me to do? Which root? 2 on bottom is the square root, so that's going to be the square root of 4 cubed. What's the square root of 4? 2. 2 cubed is 8. Or let's say I did 81 to the 3/4. 81 to the 3/4 would mean do the 4th root of 81 and then cube it. The 4 is on bottom, so that's your root. The 3 is on top, that's your power. 4th root of 81, that's one you might not know off the top of your head. Anybody know the 4th root of 81? Happens to be a nice number, it's 3. This is 3 cubed, and 3 cubed is 27. All right, so the kind of homework problems you're going to see. You're going to have things like this. You might have 16 x cubed y to the 5th to the 3 halves. What would you do with 16 x cubed y to the 5th all raised to the 3 halves? Well, we've got stuff inside a parenthesis with an exponent on the outside. What does this exponent do? It goes in, it's kind of like a distributive property. So we're going to have 16 to the 3 halves times. What happens when I take x cubed to the 3 halves? I multiply those exponents, so I get x to the 9 halves. Same thing with the y to the 15 halves. The last thing you should do on this one is simplify 16 to the 3 halves. How much is 16 to the 3 halves? Well, the 2 on bottom tells you to do a square root. Square root of 16 is 4, and then 4 cubed. 64. So final answer, I would write 64, x to the 9 halves, y to the 15 halves. Questions on that? Okay, how about 8 x to the 3/4 y to the negative 1/2 divided by negative 4 x to the negative 5/4 y to the 2/3. What would you do to simplify that? Well, I would start with my numbers out front. 8 divided by negative 4. Does that reduce at all? Yeah, 8 divided by negative 4 is negative 2. What about the x's? What would you do with the x's? All right, you've got 2 options. Option number 1 is go ahead and subtract. So you're going to have 3/4 minus negative 5/4. The other option is to take this x, which has a negative exponent, and bring it to the top, and at the same time take this y, which has a negative exponent, and bring it to the bottom. And that's what I would prefer to do. We make fewer mistakes with our positives and negatives when we do it that way. So I'm going to write x to the 5/4, x to the 3/4. I'm going to take this negative exponent on bottom, bring it to the top, and then I'm going to take this negative exponent and put it on bottom. Those things that have positive exponents, they don't move. They stay right where they were. Okay, so now I think I'm ready to give my final answer. Final answer is going to be negative 2. What's x to the 5/4 times x to the 3/4? X to the... What do you do with your exponents there? You add them. You're multiplying 2 things together, you add your exponents. How much is 5/4 plus 3/4? 8/4, which is a fancy way of saying 2. So that would be x squared. Divided by, down on bottom, same deal. We're multiplying things together, so we add our exponents. What's 1/2 plus 2/3? Well, unfortunately, you have fractions with different denominators. What do you have to do when you have fractions with different denominators? You got to have a least common denominator, multiply, add together. I think I would probably cheat at this point. Well, it's not cheating. I would do 1/2 plus 2/3 and ask my calculator to turn it into a fraction. Looks like it's 7/6. Y to the 7/6 would be my answer. So we're using all of the same rules that we used in section 10.1. The only difference is now our exponents have fractions in them, which makes them a little bit harder. But again, using your calculator, dealing with the fractions really shouldn't be that bad. Use your calculator to add, subtract, multiply, and divide all the fractions, and you should be okay. Questions on that?